Okay, so I think I saw everybody get a rectangle. That was close. And then when I did D, where I'm finding that average area, or finding the area of the rectangle, I just did 15, and I multiplied that by 12 minus negative 12. If you did 24, you don't have to change it. It just kind of made it easier for me to move on to the next steps of the problem. All right, and then I did a shortcut when I wrote it here. But to find the area under a curve, it is the integral. And we're finding the area from when t is negative 12 to where t is 12. So that's the integral from negative 12 to 12, the upper and lower limits of the function. All right, so I used 15. That was just a guess. And so when I did my area for my rectangle, I did 15 times 24, which is 360. You guys, if you did a different height, it's fine, whatever you got. And then in the calculator, you can do the integral and then do the whole function. Or you can type the function in y equals, however you want to do it. All right, what did you guys get for this one? Anybody? Great. So I was pretty close. And I saw a lot of you picked 15, but that's not exactly right, but it's close. All right, and then for G, I wanted you to write an equation. So those areas should have been equal if I drew the perfect rectangle. So I wanted you to write that your temperature was T average. All right, and then multiply that by how you got 24. So how did we get 24? Right. All right, and then that should have equaled the integral from a to b of the function t dt. All right, that's what I wanted you guys to do for G. All right, and then for H, I wanted you to take that function and solve it for T average. What would you do with that B minus A? Divide by it, or I'm going to multiply it by the reciprocal of it. All right. That is actually the formula to find the average value of a function. So did anybody actually do it for this particular problem? Like, what is the average temperature? Did anybody figure it out? 15 point. Good. So if you pick 15 degrees, you were really close. If you didn't, it's fine. No big deal.
So does it really matter if you do the 1 over b minus a? Because we divided by b minus a, we got the exact same answer.
Yes. Well, it doesn't matter for this particular problem, but this is the formula that we're going to use.
Okay.
All right, it's okay. We're going to write it on the other side. So this assignment is all about finding the average value of a function on an interval. And the AP people really like to put these on the free response questions, or they'll write it in a way, like they'll give you the form, like it's already been applied, and it was like, what does this mean for this problem? So it is going to be a tested question for sure. So we want to find the average value of a continuous function of f over the interval from a to b. We're going to call it f average, and AVE is a subscript. So f average is going to be equal to 1 over b minus a, that comes from your interval, times the integral from a to b of f of x dx. Okay, that is our formula that we're going to use. And I just wanted you all to do that temperature problem to kind of use the formula before you really saw it, so hopefully it will help you remember it. All right, on example 1, we're going to do 2 things. We have 2 examples. We're going to do 2 things on each of them. First, we're going to find the average value of the function over the interval. So let's just do that. So for A, we have this function in that interval. So I'm going to call it f average. It's going to be equal to, so in front of the integral, we're going to do 1 over, what is it for this particular problem? 2. So 3 minus 1. This is A, and this is B. Of the integral from 1 to 3, so you put A and B there also. Now, I don't really like the way this is written to be able to find the integral. So I'm actually going to move over a little bit to the side and simplify this a little bit more. So let's go ahead and divide each of those by x squared. So x squared divided by x squared is 1. 1 over x squared is 1 over x squared. And then how do I write 1 over x squared if I want to find the integral? Good, x to the negative 2. All right, that's what I'm going to use as my integrand. Okay, so let's do some problems. Let's go ahead. Now, I can move that 4 out to the front, just using properties of integrals. I can go ahead and subtract 3 minus 1. Oh. All right, so we're not looking at the 4. The 4 is moved to the front. We want to find the antiderivative of 1 with respect to x. What do y'all think? X. All right. Then we want to find the antiderivative of x to the negative 2. What do we do to the negative 2? Add 1 to it. What are we going to get? Negative 1. And so we divide by our new exponent, and then we have our new exponent. Now, we haven't worked definite integrals in a while, but this is definite integral because we have the upper and lower limits. Do I worry about plus c with a definite integral? No. So we close off the box, and then we go from 1 to 3. All right, and then I'm going to clean that up a little bit, and then we'll use our fundamental theorem of calculus. So 1/2 times 2 is 2. All right, and then 1 over negative 1 is obviously negative 1, so minus. And then what does x to the negative 1 mean? 1 over x. Good job. Okay. So that fundamental theorem of calculus. I'm going to have to plug these in, right, and subtract. Which do I plug in first, the 1 or the 3? The 3, so the top, the upper limit. So we put 3 in. All right, and then do I add or subtract these values? Subtract. And then I put 1 in. You guys remember that? It's been a while. We're still looking for the average value of the function, so I'm going to keep calling it f average. Okay. So what is 3 minus 1/3? How many thirds is 3? 9. So 9/3 minus 1/3, 8/3. All right. 1 minus 1 obviously is 0. So the average value of this function is going to be 16/3. All right, So that's just saying that over that interval, if you take, there's an infinite number of values. If somehow we could take all of those and divide them by infinity, that's what we would get. That is the average value over that interval. Okay, the second part of this problem asks us to do something else. And there is a mean value theorem for integrals. It's not listed as a topic for the AP test, but we did the mean value theorem before with derivatives, and it was saying that the function is continuous. There's a point where the average rate of change equals the instantaneous rate of change. That was the mean value theorem. So for integrals, they're saying that there's a point where the function actually equals the average value of the function. So we're going to find when that happens. So we're going to find all the values of x in the interval for which the function equals its average value. And that's pure algebra. So that's taking the function and setting it equal to the average value. All right, so our function is 4 times x squared plus 1, I don't know what's going on, over x squared. We want to know when that equals 16/3. All right, what would y'all do to solve this equation? Y'all got this. This is algebra. You would cross multiply. All right, and then we just have some distributing to do, and we'll get there eventually. Okay. So we want to make sure that the answers we get are in the interval that we're talking about. So the square root of 3 is definitely between 1 and 3, but what about the negative square root of 3? It is not. So the only answer is the square root of 3. All right, are y'all okay? Okay, we're going to do the other side, and it does have some trigonometry in it, but I don't think it's really any more difficult than the one we just did. All right, so we're going to use the formula to find the average value of the function by saying that f average is equal to 1 over, and then this is going to be a, this is going to be b, and we multiply that by the integral from 0 to pi over 2 of the cosine of x dx. So as soon as I take the integral of the cosine of x dx, I don't write the integral sign anymore. And what is the integral of the cosine of x? Sine of x. And we're going from 0 to pi over 2. Okay. What about this 1 over pi over 2? What is that going to be? 2 over pi. All right, so then we plug in our upper limit, and then minus, plug in our lower limit. Okay, so what is the sine of pi over 2? 1. Good. What is the sine of 0? 0. Good. All right, so the average value of this function on that interval is 2 over pi. Okay, so you guys still have your calculators. We cannot do the second part of this question without a calculator. It's beyond our ability. So we want to find when the original function, cosine of x, is equal to 2 over pi. We don't have that ability. So we're going to let the calculator figure it out for us. So on your calculator, we're going to say that y1 is cosine of x. We're going to say that y2 is 2 over pi. Get that typed in, and then I'll help you with your window in just a second. All right. And we only care about the interval from 0 to pi over 2, so that's what I'm going to change my window to. So we'll call the x min 0 and the x max pi over 2. Now the y, we might also need to change just so we can see a good portion of our function. So let's just, on that, let's just go from like -2 to 2 on the y min and the y max. All right, then go ahead and look at your graph. Let me know if something looks weird. All right, I don't have the TI calculator on here, but I do have Desmo. So I have, it should look something like this. I couldn't cut it off at pi over 2, so I have a little more than you guys do. Does it look like that? But a smaller version? Okay. All right, so we need to find where these two graphs intersect. Y'all remember how to do that on your calculator? Second, trace, and then I think it's number 5, intersect. And on here, I can just type it. And it tells me. So you guys should get 0.881. Is that what you got? Sweet. Ah. All right, so x is approximately 0.88. All right, so do you guys have any questions about finding the average value and then finding when the function equals the average value? Okay. Okay, so your assignment is out of the book today.